What do 800,000-year-old ice cores tell us about climate? Imagine holding a tiny bubble of air from hundreds of thousands of years ago. These bubbles are trapped inside ice cores drilled from deep in Antarctica. They hold clues about Earth's past climate. Over the last 800,000 years, scientists have carefully examined these ice layers to understand how our planet's climate has changed over time. Each layer of ice represents a year or a season, like pages in a history book. As snow falls and compresses into ice, it traps small amounts of ancient air. By analyzing these bubbles, scientists can measure the levels of greenhouse gases like carbon dioxide and methane from long ago. This helps us see how these gases have fluctuated over hundreds of thousands of years. The data shows that Earth's climate has gone through repeated cycles of cold and warm periods. During cold times, large ice sheets covered much of North America and Europe. These are called glacial periods or ice ages. Between these cold spells, the climate warmed up, creating interglacial periods where life thrived more easily. The ice cores reveal that temperature changes closely follow the levels of greenhouse gases. When carbon dioxide and methane levels rise, temperatures tend to increase. When these gases drop, the climate cools down. One surprising fact is that current levels of carbon dioxide are much higher than any natural cycle seen in the past 100,000 years. Today's levels are about 50% higher than the highest natural peaks. This increase is mainly due to human activities like burning fossil fuels such as coal, oil, and natural gas. Ice cores also help scientists estimate past temperatures by measuring water isotope ratios. These ratios change with temperature, so they tell us how much warmer or colder it was during different times. For example, during the medieval warm period, the climate was warmer, while during the Little Ice Age, it was colder. Understanding these long-term patterns helps us see how Earth's climate responds to changes in greenhouse gases. It also provides context for current climate change, showing how unusual today's conditions are. These ancient records reminded us that Earth's climate is always shifting, but human activity is now causing rapid changes that could affect ecosystems and societies worldwide. In essence, these ice cores act like a time machine, revealing Earth's climate story over hundreds of thousands of years. They confirm that greenhouse gases are key drivers of climate change and show how our current situation is unlike anything seen naturally in the past. This knowledge helps us understand the forces shaping our environment and guides efforts to protect our planet for future generations.